Good day, everyone, and welcome to where we are putting together solutions for students in the area of additional mathematics. This area has proven to give students a lot of trouble. And remember that additional mathematics falls under the Caribbean Secondary Examination Council, CSEC. In this video, we'll be looking at probability and statistics, and specifically the 5 years from May 2017 until 2022 in paper 2. Even though that covers 6 years, let's recall that one of those years there was no paper 2 due to the pandemic. Don't forget to like the video and add any comments down below so we can help make other videos for you in whichever areas that you are struggling with. Don't forget to look at the description down below where we have outlined the order we suggest that you go through all of these solutions section by section, this being the last and fourth section, where we have given 2 videos in each area. One on the first 5 years of past papers and then on the next set.
Let's look at the 4 major topics in additional mathematics, and this video specifically looks at section 4, probability and statistics. This question is tested for 5 multiple choice questions out of the 45 in paper 1 and 1 full question worth 20 marks out of the possible 100 marks in paper 2. We can see the suggested symbols to be used from the syllabus, and this topic is broken up into 2 major parts. First of all, data representation and analysis, and then probability. The syllabus itself speaks to us about mode, mean, median, range, interquartile range, semi-interquartile range, variance, and standard deviation of ungrouped and grouped data, quite similar to the CSEC Maths syllabus. It also goes further by looking at stem and leaf diagrams, as well as box and whisker plots. We look at the laws of probability, the fact that the summation at any space is equal to 1, and the range where the probability of an event occurring, the minimum is 0 and the maximum is 1. In terms of probability, it's related to set theory with regards to the addition rule, mutually exclusive, and independent events. Conditional probability is also expected to be covered. And finally, space diagrams, tree diagrams, and Venn diagrams.
May 2017, number 7A. The probability of a final year college student receiving a reply for an internship program from 3 accounting firms, Q, R, and S, is 0.55, 0.25, and 0.20 respectively. So we are seeing the probability of these 3 firms. The probability that the student receives a reply from firm Q and is accepted is 0.95. The probability that a student receives a reply from firms R and S and is accepted is 0.30 for each of them. Draw a tree diagram showing to illustrate the information above. So let's recall that when the student is applying, there are 3 possibilities. So the first possibility would be firm Q, and the probability of that is 0.55 of getting a reply. And from R, that second firm, the probability is 0.25 or 25%. And from S, it will be 0.20. And of course, when we're looking at the sum of probabilities at a point of an option, Q, R, and S, it must total 100% or 1.0. And if we add up 0.55 and 0.20, that will give us 0.75, and 0.25 will give us 1. So it makes sense. Now what happens at Q? Two options occur. Either he is accepted, and we will indicate that by an A, and there's a possibility of a 95% acceptance, 0.95, or he is not accepted, so we'll indicate that as A prime. And of course, it will give us a 5% probability, because at Q, there are only two possibilities, and that total will be 100% again, so 95% plus 5%. Similarly, at R, acceptance possibilities, they said, with 30%, and of course, not being accepted would be 70%. Similarly, for S, same thing as at R, acceptance possibility is 0.30 or 30%, and not being accepted will be 70% or 0.70. So let's now go on to part 2, where it says to determine the probability that the student will be accepted for an internship program. So, if that's the case, where will they be accepted? If we look at our tree diagram, we can see there are 3 A's on the right hand side. So either he can follow the first path on the tree diagram, the highest set of branches, which will be Q and A. So that can be indicated as follows. The probability of acceptance would be Q and A, which is one way. The other way would be from the firm R and being accepted. So either the first part, which was blue, or the second part, which was gray, and O is represented as an addition in probabilities. So we say plus P by R intersect A, R and A. Or there's a third possibility of being accepted by firm S. So we have some green arrows there. So in this case, it will be by passing through firm S and being accepted. And will be using an intersection. So it's plus the probability of S intersect E. And of course, if we're substituting the values now for probability, when we speak of the fact of intersection, or we're saying and, so we're looking at the first dark blue arrow, it's Q, that probability, and the probability of acceptance. Those two things must happen. And when we say and in probability, it means to multiply. So this can be substituted as the probability of A is equal to 0.55 multiplied by 0.95. Or if we're looking at the middle or gray pathway, then it'll be 0.25 multiplied by 0.30. And for the light green pathway at the base, it will be 0.20 multiplied by 0.30. And now we simply use our calculators, and that will give us 0.5225 plus 0.075 plus 0.060, which gives us a total probability of being accepted to be 0.6575, or 65.75% probability of being accepted by one of these three firms. May 2017, number 7, part B. Table 2 shows the length in centimeters of 20 spindles prepared by a carpenter to build a railing for an existing staircase. So if we look at table 2, we can see the 20 different lengths. Determine, part 1, the mean length. Mean is the same as saying the average, because mean here means arithmetic mean. So how do we find the average of 20 numbers? The easiest way is we can add up all the numbers and then divide by 20. And that total will be 434.7 divided by 20, which works out to be 21.735 centimeters. That will be the mean length. Let's go on to part 2, where we have to determine the modal length. So if we look at the values, Each of the values appeared one time except for 25.2. That appeared twice. So 25.2 was the most frequent length out of the 20 spindles. As such, 25.2 centimeters is the modal length. Part 3, determine the median length. So if you recall that there are 20 spindles, and to find the median, we need to have the numbers placed in ascending or descending order. And if we go from the top row, from left to right, we can see it's increasing up to 24.4. And then it goes to the second row, 25.2, and it continues increasing up to 38.4. As such, if we read across from left to right, the first row followed by the second row, those 20 values are already in ascending order. And if we want to find the median of 20 items, then since it's an even number, it will have two items in the middle of 20. The 10th term, which works out to be 24.4, as we could see, it's the end of the first row, and the 11th term. And the 11th term is 25.2. So the median will be the middle of those two numbers. So we add them up, 24.4 plus 25.2, and then divide by 2. So the median works out to be 24.8 centimeters. Let's go on to the next part, where we have to determine the interquartile range. And in order to determine the interquartile range, we need to know Q1 and Q3. The median was Q2. So if we look at the first 10 numbers that were given, the first 10 values in the first row, how do we find the middle of that? Because that will give us the value for Q1. Since there are 10 values, which is an even number, the middle of that will be two values, the fifth and sixth values. So the fifth value is 11.0 and the sixth value is 12.6. So this purple arrow indicates that the median will be between 11.0 and 12.6. So Q1 will be 11.0 plus 12.6 divided by 2. That will find the middle. That is 23.6 divided by 2, which works out to be 11.8 centimeters. So that is the value for Q1. Similarly, for Q3, it will be the middle of the last 10 values, which is row 2. So if we have 10 values, it will be the fifth and sixth values, or if we count them in order here, it will be the 15th and 16th values, which will be between 29.1 and 30.4. So Q3 will be 29.1 plus 30.4 divided by 2. That will give us the middle of them, the Q3 value. 29.1 plus 30.4 is 59.5, and if we divide by 2, we're going to get 29.7 centimeters. So we know Q1 and we know Q3. In order to now get the interquartile range IQR, it's the difference between Q3 and Q1. So we just substitute 29.75 minus 11.8, and that gives us 17.95 centimeters as the interquartile range. Let's now go on to the next part, part C, where it is said a school cafeteria sells 20 chicken patties, 10 lentil patties, and 25 saltfish patties daily. So we have three different items. On a particular day, the first student ordered two patties, but did not specify the type. The vendor randomly selects two patties. So for part 1, calculate the probability that the first patty selected was saltfish. So if we consider the probability of selecting saltfish, the probability of choosing that outcome out of all the possible outcomes that there are, then the probability of saltfish, let's say probability of S1, will be 25, because there are 25 choices for saltfish out of the total, which is 20 chicken patties plus 10 lentil plus 25 saltfish. So 25 all over 20 plus 10 plus 25, which is 55. So the probability of selecting saltfish as the first item is 25 out of 55. Or we can reduce that, and that will give us 5 out of 11. Let's go into part 2. Given that the first patty was saltfish, calculate the probability that the second patty was not saltfish. So if we consider now that we're linking it to the first patty, right, the first patty selected was already saltfish, then the probability of choosing a second patty where we know the first patty was saltfish, right, the second patty was not saltfish, so we'll indicate that by writing S2 and put a bar on top. So it's not saltfish as the second patty compared to the first patty being saltfish. So if it's not saltfish, what are the possible outcomes? We can choose out of the 20 chicken patties or the 10 lentil patties. So there are 30 possible choices to be made out of the total. And what is the total? 20 chicken patties, 10 lentil patties, and 24 saltfish patties. Because the first selection was a saltfish patty. So we don't have 25 anymore, but we have 24. So we can work that out. 20 plus 10 is 30 over 54. Or that can be reduced, divided by 6 throughout. So it'll give us 5 over 9. May 2018, number 7, part A. The number of runs scored by a cricketer for 18 consecutive innings is illustrated in the following stem and leaf diagram. And if we look at the diagram, we can see that the least score that the cricketer made was 2 and the greatest score was 47. And of course, with that, a key was given showing that 0/6 means 6. So let's now look at part 1. Determine the median score. So let's recall that we have 18 values. And if we want to find the median of that, first of all, it must be in either ascending or descending order. And that is given by the stem and leaf diagram already. And secondly, because 18 is an even number, they are going to end up with two numbers in the middle, which will be half of 18 is 9, so the ninth term and the 10th term. So we can see 2, 3, 6, and 7, that's 4 terms, 10, 13, 15, 18, 19. 19 is the ninth term. So that's the ninth term, and the following term will be the 10th term, which is 24. So the median score will be halfway between 19 and 24. So we can find the average of those by adding 19 plus 24, which is 43. 2 into 43 is 21.5. So that is our median score. Let's now go on to part 2, where they're asking us to calculate the interquartile range. In order to find the interquartile range, we must first find the first quartile and the third or lower and upper quartiles. So if we look at the first half of values, that was from 2 to 19. There were 9 values. And as such, 9 being an even number, that the middle of that will be one value, which is the fifth number. So we have 2, 3, 6, 7, that's 4 values. So the fifth one will be 10. So we say that Q1 is equal to 10. And similarly, let's look at the second half of values, which started at 24 and ended at 47. There are 9 values there. So the middle of 9 consecutive values will be the fifth value. So 24, 24, 26, 28, that's 4 values. 31 will be the fifth value. As such, Q3 is equal to 31. So if we now want to calculate the interquartile range, let's recall that the interquartile range is equal to the difference between Q3 and Q1. And we can substitute. We know Q3, which we have in green, is 31, minus what we have in purple for Q1, which is 10. 31 minus 10 is 21. So the interquartile range is 21. Let's go on to part 3. Construct a box and whisker plot to illustrate the data and comment on the shape of the distribution. So let's recall that when we're making a box and whisker plot, we must incorporate the least value, which will be on the left side, and that from our table is 2. And on our extreme right, at the end of the right whisker, will be our largest value. Our maximum is 47. And there will be 3 values in the middle, Q1, Q2, and Q3, which is 10, 21, and 31. So we can see our box and whisker plot. And from here, we can tell that the whisker on the right-hand side, which is from 31 to 47, is much larger than the whisker on the left-hand side. As such, we can say that it is positively skewed or skewed to the right, as the whisker to the right is greater than the whisker to the left. May 2018, number 7B. Insecticides A, B, and C are applied on lots Q, R, and S. The same crop is planted on each lot, and the lots are the same size. The probability that a group of farmers will select A, B, or C is 40%, 25%, and 35% respectively. The probability that insecticide A is successful is 0.8, that B is successful is 0.65, and that C is successful is 0.95. Part 1. Illustrate this information on a tree diagram showing all the probabilities on all branches. So, if we consider that we have 3 choices at the beginning, the first choice being A, at that lot we're going to put in a probability of 40% or 0.40. And the next choice we have is B, and B has a probability of 25% being selected, 0.25. And of course, if we have 3 choices, the total must be 100%. It's one of those 3 choices. So if we had 40% above and 25% in B, that's 65%, and 35% in C, which was given, or 0.35. Now, for each of these, we're going to have 2 options. When we spray the insecticide, either it is going to work, and if it works, then it has an 80% success rate, or 0.80. And if it does not work, then it will be not working at 20% probability. Because at A, the options are either W, work or not work, which will give us a total of 100% probability at A. Similarly, at B, the success rate is given as 65%. And of course, if it's possible that it will be successful, then similarly, it can be possible that it's not successful. And what would that be? That would make up 100%, so that will be 35%. And for C, the success rate is 95%. So the probability that it will not be successful is 5% or 0.05. Let's now go on to part 2, where they're saying an insecticide is selected at random. Determine the probability that it is unsuccessful. So that means that if we're looking at the red outcomes, unsuccessful means that it does not work. So it will be W prime. So how do we represent this? We can say that at the point of A, choosing that lot, it cannot work. So the 2 blue arrows indicate such. So that can be written as probability of A and not working. And similarly, what's another way for it not to work? It can go through B using the gray arrow and not work. And how do we represent that? By putting B intersect W, not, or W prime. And the choices are blue or gray. So how do we write or using probability statements? By using an addition sign. So you can see that there. Is there any other way for it not to work? Of course, if you choose C as the insecticide and it does not work, the green arrows indicate this. So either we have the blue arrows or the gray arrows or the green arrows. And or is brought up by an addition. Now that we're going to substitute for that, when we say looking at the two blue arrows, then it is must go through the first blue arrow and the second blue arrow. And how do you represent and in probability statements? By multiplication. So we say that that will be 0.40 multiplied by 0.20. And we can look at the gray arrows. Then it must be the first gray arrow and the second gray arrow, that pathway in the tree diagram, in order for it to not work. So that will be 0.25 multiplied by 0.35. And for the green arrows, similarly, it will be 0.35 multiplied by 0.05. And now we can use our calculators, and that will give us 0.08 plus 0.0875 plus 0.0175, which totals 0.185, meaning that there's an 18.5% chance or probability of this not being successful. And let's go on now to the next part, which says that a regular six-sided die is tossed 2 times. So part 1, calculate the probability of obtaining a 5 on the second toss, given that a 5 was obtained on the first toss. Now, if we recognize it's the same die, that after we roll it the first time and get a 5, what is the probability of getting a next 5? These two things are completely independent of each other. As such, the probability of getting a 5 on the second toss is 1 out of 6, because 5 is one outcome out of a possible of 6 outcomes, and it's independent from the first toss. Now let's do that in comparison to the second part, part 2. Determine the probability that a 5 is obtained on both tosses. So it means that must indicate both the first toss S1 and the second toss S2. And as we said above, that when we're considering and, it means that we're going to have a multiplication. So the probability of tossing a 5 the first time is 1/6, because there's 1 5 out of 6 possibilities in the six-sided die. And when we do the second time, it's 1/6 again. So 1/6 multiplied by 1/6 means it's 1 out of 36. So we see we have two pretty similar things between part 1 and part 2. So like the final part of the question, part 3 is saying, explain why the answers in C part 1 and part 2 are different, even though they're somewhat similar. And that is because tossing of the two dice, or the die twice, in part 1 were two independent events. One was not hinged on the other. The fact that in part 1 you just needed to get a 5 on the second toss, while in part 2 the events were dependent. You must get a 5 and get a 5 the second time. May 2019, number 7A. The weights in kilogram of students in a grade 5 class are displayed in the following stem and leaf diagram. So if we look at the diagram, we can see that it's a double stem and leaf plot, meaning that we're accustomed to 2 columns usually, but now we have 3. So the middle column works for both the left side information, which are boys and their weights, and it works for the right side as well, for the girls' weights. And of course, to fully explain this, we need to have a key, and this is used to explain fully the information. So where we have boys 8/2, the center column carries a place value of tens. So the 2 will be worth 20. And moving to the left of that, it will be 28. that will be how many kilograms for the weight of that particular boy, the lightest boy in the class. And then after him, the next lightest boy is 29. And then following that, the next lightest boy will be 33. So it's starting in the middle column and increasing as it goes to the left. And let's now look at the key for the girls, where it says 2/8 means 28. So similarly, the center column has place values of 10, so the 2 is worth 20, and the lightest girl is 28. And then the next lightest girl is 28, and the following lightest girl is 29, and then 32. So in the case of this double stem plot, the center column now increases to the right or left according to which side that we're looking at. So now let's see what happens in part 1. State the number of students in the class. So there are boys and there are girls, so all we need to do is add up how many there are. So there are 15 boys and there are 14 girls. So 15 and 14 is 29. Only one mark is required. Next part 2. Construct one box and whisker plot for the entire grade 5 class, meaning we're combining the boys and girls. So what that is telling us is that when we're looking at this box and whisker, remember that it gives some vital information, such as what is the minimum value in the entire combined class, what is the maximum value in this grade 5 class, the first, second, and third quartiles, meaning the 25th percentile, 50th percentile, and 75th percentiles. So we need to do that for one large piece of information. And presently in the double stem and leaf diagram, it's separated into two. So let's combine them so we can start writing it, such as 28, 28, 28, 3 sets of 28 in terms of we're going in ascending order, and then two 29s, and it goes straight up until the largest value is 51. So it is incorporating all the weights in ascending order, irregardless of whether or not it's a boy or a girl. So now that we have that, we can get the vital information required. We can easily tell the minimum value in the class in terms of weight is 28 and the maximum weight is 51. So we know two values to go in this box and whisker plot. We now need to figure out what is the median or the 50th percentile or the second quartile. So if we know we have 29 students as we got in part 1, and we want to find the middle of that when we put in ascending order, 29 divided by 2 is 14.5. So it will be the 15th term will be the median. And just to recall that if we have an odd number of terms, there is only one term that will end up directly in the middle. So that's the 15th term. And if we check it, we have 9 in the first row. So 10, 11, 12. So this will be 39. So 39 is the middle of it. So we can write that Q2 is equal to 39. Now we had 29 terms in all, and we now split it into two. So we have 14 terms before the 39, before the median. And if we want to get the middle of 14 terms, remember 14 is an even number, we'll end up with two terms in the middle. So the middle of 14 is 7. So the two middle terms will be the 7th term and the 8th terms. And if we count it out, 28, 28, 28, 29, 29, that's 5, 32, 32, that's 7, and 33 is 8. As such, Q1, the first quartile, or the 25th percentile, falls between 32 and 33, between the 7th and 8th terms. So we can write that Q1 would be the average of that. 32 plus 33 divided by 2. And if we work that out, 32 plus 33 is 65. 2 into 65 is 32.5. So that's the first quartile. So we have the first quartile, the second quartile, and we now want to get the third quartile. And similarly to what we did just now, to work out the first quartile, In order to work out the third quartile, we look at the second half of information, meaning after the 39 we have circled, which is the median, we have 14 values in terms of weight. And the middle of that will be the seventh and eighth terms, and that will be between the second and third 41s. And this is quite obvious what the Q3 value is, but let's show the working. So Q3 will be between 41 and 41, and you find the average of that, and that will give us 41. So we know the minimum weight, we know Q1, Q2, Q3, and we know the maximum weight. So we can now construct our box and whisker plot. And now let's continue with the next part of the question, where in part 3, they're saying the standard deviation of the weights of the boys is 5.53 kilograms. So they took the 15 values of the boys and worked out the standard deviation, and this is such. Determine the standard deviation of the weights of the girls. And remember, we have 14 girls, and you can check them above. We have 3 and 7, 10 and 4, 14. Provide an interpretation of your answer for the girls compared to that given for the boys. So, first of all, we need to calculate the standard deviation of the girls' weights, and then we could compare it. So how do we do that? Let's recall there are a couple different formulas we can use to find standard deviation. So let's use this one, where standard deviation is equal to the square root of sigma x squared divided by n, the number of terms, which is 14 for girls, minus sigma x on n all squared. So let's see if we can write out these 14 terms as a table. And if we do that, we can see the minimum term is 28, 28, 29, and it keeps increasing until we reach 40, 41, 41, 42. So we have 14 terms in all. And out of those 14 terms, we can now find the total, which is sigma f. Remember, sigma indicates that what we're doing is we're adding up all the values, which works out to be 495. So we know sigma f is 495, we know n is 14, so we can substitute here. We need to know sigma x squared. So for each term of x, we need to find the square of it, the x squared term. And if we do that, we can see 784 is 28 squared, straight up to 1764 for 42 squared. So if we total that, it gives us 17,829. So if we now substitute that into the formula, it will give us 17,829 divided by 14 minus 495 divided by 14 all squared. And we want to find the square root of that to give us the standard deviation. So the first division works out to be 1273.5 minus the second division, which is approximately 1250.1. And if we subtract there, we're going to get 22.4. So the square root of 22.4 is approximately 4.83. And this is the two decimal places, because the standard deviation given to the boys was also to two decimal places, 5.53. Now we can compare the girls' and boys' deviations. So since the girls' standard deviation, which is 4.83, is obviously less than 5.53, the boys' standard deviation, this is indicating that there is a more clustering of the girls' weights, while the boys' weights are more spread out. Let's go on to the next part. Determine the number of students above the 20th percentile for this class. Now we worked out the 25th percentile, the 50th percentile, and the 75th percentile, Q1, Q2, and Q3, and we need to work out for the 20th percentile. So let's recall the formula. The percentile to any value would be k over 100 times n plus 1, n being the number of students. And in this case, we're talking for the entire class, which we worked out in part 1 to be 29. So we can substitute here, and we want to work out for the 20th percentile, so we say P20, k being 20 here, will be 20 over 100 multiplied by 29 plus 1, because there are 29 students in the class. And we could simply work this out. 29 plus 1 is 30. 20 into 100 is 5. 5 into 30 is giving us that the 20th percentile term is the 6th term. So if we look at the list of values in ascending order we had in part 2, and we count it to which is the 6th term, we can see the 6th term is the first 32. 28, 28, 28, that's 3. 29 is 4, 29 is 5, 32 is 6. So this, in terms of the 20th percentile, which is the 6th term, that value for the entire class is 32. So let's go back to the question and see what it's asking. Determine the number of students above this percentile. So they want to know how many students are above 32. And since we have two values of 32 there, the first one we have in the blue rectangle we just brought up is the 6th term, and we have another one, the 7th term. So therefore, how many students are above the 7th term or above 32? And that will be 29 minus 7. So there are 22 students whose weight is above the 20th percentile or above 32 kilograms. May 2019, number 7B. A vendor has 15 apples on a tree, 5 red, 6 green, and 4 yellow. A customer requests 3 apples but does not specify a color. Determine the probability that the apples chosen, part 1, contain one of each color. Now, if we look at this question, it does not specify what order the apples are to be picked in. So there may be multiple ways in order to select one apple from each color, and we need to work that out. So let's consider the probability of selecting each of these. So we can pick a red, and then a green, and then a yellow. That's one way. Or we can choose another order, and in probability, O is represented as add. So we can still pick a red first, but we can switch it and pick a yellow second and a green third. So these two options were when we picked the red apple first. Now we can adjust it by picking a yellow apple first. And then we can pick a red followed by a green. Or we can still pick a yellow first, but then a green followed by a red. So we picked red first and gave the two versions. We picked yellow, and now we're going to pick green first, and then a red and a yellow. Or we can pick green and then the opposite. So now that we know that, we can work out the actual probabilities. So for the first one, the probability of picking a red, if we look at it, we have 15 apples. So that is our total possible selections. And out of the outcomes that we want, to pick a red, there are 5 choices. So that's 5 out of 15 times picking a green will be 6 out of how many is left? 14, because one was already chosen. And then a yellow, which will be 4 out of 13, because 2 were already chosen. And if we pick the order of red and then yellow and then green, well, the red will still be 5 out of 15, and the yellow will be 4 out of 14 because one was selected, and the green will be 6 choices out of what is left? 13. And we go on with the yellow, red, green. So if we're picking yellow first, then it's 4 out of 15. And then the red will be 5 out of what is left? 14. And then the green will be 6 out of 13. And we can continue with yellow first, and then green, and then red. So yellow will be 4 out of 15. And then green will be 6 out of 14. And then red will be 5 out of 13. And then we go on with the choice of picking green first. So green will be 6 out of 15. That's the possibilities. And if we have to pick red now, there are 5 possibilities out of what's left, 14. And yellow will be 4 out of 13. And for the last one, green first, 6 out of 15. And then yellow is 4 out of 14. And then the red will be 5 out of what's left is 13. And if we look at all of these, we can see the denominator is the same throughout. 15 by 14 by 13 for all 6 fractions. And the numerators are all the same. So we can say that to work this out will be 6 times 4 times 5 all over 15 times 14 times 13. And that simply works out to be 720 over 2,730. And that is our probability. We can reduce it and it will give us 24 out of 91. Or we can convert it to a decimal and it works out to be 0.264 as the probability. Or 26.4% probability that if we're selecting 3 apples at random, that they will have one color each of a red, of a green, and of a yellow. And let's go on to part 2. Here, they're saying that determine the probability that the apples chosen are all of the same color. So that means if they're all of the same color, they can be all red, all 3 of them. Or they can be all green. And remember, or is represented by addition. Or they can be all yellow. So if they're all red, it means that the first choice is 5 out of 15. And then when we're choosing red again, it'll be 4 because 1 was already selected, 4 out of 14 and 3 out of 13. So it must be 5 by 4 by 3. And if we're selecting green, it'll be 6 out of 15. And then we're selecting another green, 5 out of 15, that's the probability. And if we have a choice again and we selected another green, it'll be 4 out of 13. And finally for yellow, similarly 4 out of 15. And then we selected one, we're left with 14 of these apples. And we want to select a yellow, there's 3 out of 14 is a possibility. And we select again 2 out of 13. And we can now simply work this out. 5 by 4 is 20 by 3 is 60. 60 over 2,730 plus 6 by 5 by 4. 5 4s are 20. 6 by 20 is 120. Plus 4 3s are 12. 12 2s are 24. So we have 3 fractions with the same denominator. We can simply add 60 and 120 is 180 and 20 is 204. So the probability of selecting all of the same color is 204 out of 2,730. Or it can be reduced to 34 out of 455. Any of these answers are correct, any of the red ones in part 1 or in part 2. Or we can convert it to 0.075 or 7.5% probability of selecting all 3 apples of the same color. May 2021, number 6, part A. 2 fair tetrahedral dice, meaning that those dice have 4 sides, with faces numbered 1, 2, 3, and 4 are ruled. The numbers obtained on the turned down face of each dice are noted. Create a sample space table listing all possible outcomes for the 2 dice. So if we consider a sample space, then we can bring up a table with the first die on one side and the second die on the other. And we know that there are 4 possible outcomes for the first die and 4 for the second as well. So let's consider the case where in the first die, a 4 is ruled. If a 4 is ruled in the first die, what is the possibility of the numbers that can happen in the second die? Well, we can get a 4 and a 1, a 4 and a 2, a 4 and a 3, or a 4 and a 4. So there are 4 possible outcomes if the first die rolls a 4. If the first die rolls a 3, then similarly 3 1 up to 3 4. If it's a 2, 2 1 up to 2 4, and 1 1 1 2 1 3 and 1 4. So there are 16 possible outcomes when these two tetrahedral dice are rolled. So let's go on. Part B, using your sample space created in part A, or otherwise, determine the probability of obtaining a 4, part 1, on both die. So if we look at the sample space, when the first die rolls a 4 and the second die rolls a 4, then that only happens in this case. Let's bring it up with this color to surround it. We can see it 4 4, and there's only one possible outcome out of 16. So the probability of obtaining a 4 on both die is 1/16. Or we could have actually done the working where we said the probability of a 4 in the first die and the probability of a 4 in the second die would be equal to, what's the probability of getting a 4 in the first die? 1 out of 4. And for the second die, the same thing, 1 out of 4. As such, when we're incorporating both, meaning the probability of the first and the second will be 1 out of 4 times 1 out of 4. 1 quarter times 1 quarter is 1/16. But that's the other way to work it. We can simply read it off from the table because this part 1 is worth 1 mark, just as part 2, where they're saying determine the probability of obtaining a 4 on at least one die. So if we're saying that at least one of the die will give us a 4, then if we look at the first die, then we can highlight that in a little blue background where we could get 4 1, 4 2, or 4 3. So there are 3 possibilities of obtaining a 4 there on that die. And if the other die ruled a 4, then we would get 1 4, 2 4, 3 4. So let's look at the question again. Determine the probability of obtaining a 4 on at least one die. So that will be the one with the purple background, 3 possibilities out of 16. The one with the blue background, 3 possibilities out of 16. And we can also include where both die rolls a 4. So that's 3 and 3, 6, and 1, 7 out of 16. Because at least one die means that when they're rolled, one of the die could get a 4, the first die, or one of the die, the second die, could get a 4, or both could get a 4. And for the last part here, part 3, they're saying determine the probability of obtaining a 4 on exactly one die. So, slightly different to part 2. If it's on exactly one die, then we will not be counting the 4 4 possibility. So it will only be the blue possibilities or the purple possibilities, which are 3 and 3, 6 out of 16. Or we can reduce it to 3 out of 8. So let's now go on to part 4, where it says show that obtaining a 4 on both die are independent events. So let's consider where it's happening together at the same time. So the probability of rolling a 4 in the first die and the probability of rolling a 4 in the second die is 1 out of 16. We worked that out in part 1. It's the sort of peach highlight on the table. And since we're looking at independent events, we want to look at what's the probability of rolling a 4 in the first die times probability of rolling a 4 in the second die. So the probability of rolling a 4 in the first die, because there are 4 options and we can get 1 out of 4, that's 1 quarter, times 1 quarter, which works out to be 1/16. So what does that tell us? It tells us that both die are independent events because the probability of 4 1 intersect 4 2 is equal to the probability of 4 1 times the probability of 4 2. So we can bring up a smaller rectangle or write QED to show that we have proven it. Let's go on to the next part. Determine the probability of obtaining a 4 on both dice. So that is indicated in the orange or peach background. So we know that's 1 out of 16. Given, and the word given means it's conditional probability. So we're comparing that chance of 1 out of 16 out of what is given, that a 4 was obtained on at least one die. And of course, when we said at least one die, that included the blue, the peach, and the purple backgrounds. So we're comparing what's the probability of getting the peach background, the 4, 4, out of those 7 items. So we can write that the probability using conditionality equation is such that we're going to get the intersection over at least 1. And we know those values. The first value, the probability of 4, 1 intersect 4, 2 is part 1. And at least 1, 4 is part 2. So we can substitute 1 over 16 divided by 7 over 16. And when we're dividing fractions, we change the sign to multiplication and we find the reciprocal of the second item. And that will be 1 over 16 times 16 over 7, which leaves us with 1 out of 7. And we can see that from the diagram, that if we look at the colored choices, there were 3 choices of blue, 4, 1, 4, 2, 4, 3. There's a peach choice, 4, 4. And there are 3 choices in purple. So that's 7 choices. So this conditional probability is just saying what is the possibility of the 4, 4, one choice out of those 7, 1 7. May 2021, number 6, part C. The scores of a class of 30 students on a mathematics test were used to draw the box plot diagram. And we can see it brought up here. The minimum being 4, straight up to the maximum being 20. The total score possible is 20 marks. Using the box plot, determine the following. Part 1, the median score. And we can see from a box plot, which is vertically represented, that the median score, or the 50 percentile, or Q2, is represented by this purple arrow. And as such, Q2 is equal to 11. Let's go on to the next part. Part 2, find the range of the scores. And the range will be the maximum score, which is at the top, which is 20 minus the minimum score, which is 4. And 20 minus 4 is equal to 16. Part 3, determine the semi-interquartile range of the scores. And in order to do this, we need to get Q1, which is the 25th percentile, as indicated by the blue arrow, and we need to get Q3, which is the 75th percentile, which is indicated by the green arrow. So the semi-interquartile range would be Q3 minus Q1 divided by 2. And we can substitute. That will be 17 minus 7 divided by 2. And we have them color-coded in green, Q3, 17, and the green arrow, so we can see exactly where that is on the graph. And similarly for the Q1 values in blue. So 17 minus 7 is 10. 2 into 10 is 5. As such, the semi-interquartile range of the scores is 5. Let's now go on to part 4. Comment on the shape of the distribution of the scores. So if we look at it, we can see that Q2 is not in the middle of Q1 and Q3, but there's a larger space from Q2 to Q3 than from Q2 to Q1. As such, we can say that it is a non-symmetrical distribution, which is positively skewed, or skewed to the right, accordingly, if it was a horizontal diagram. Now, in the next part, a student wants to determine the mean score for the data set. Part 5, state one reason why it would be impossible to determine the mean score from the box plot. And simply, the raw data is not accessible in a box plot diagram. Only those 5 points, minimum, maximum, Q1, Q2, and Q3. So, in part 6, state what additional pieces of information would be needed to determine the measure, meaning to find the mean. And in order to get the mean, x bar, we need the raw scores to calculate it because we require sigma fx over sigma f. And we now go on to part 7. Given the sum of the 30 scores for the class is 354, that means they gave us sigma x, and the sum of the squares of the scores is 4,994. So we know sigma x squared, and of course 30 would be the number n. Determine the standard deviation for the data set. And there are a couple different formulas, but look at the information we're given. We're given n, sigma x, and sigma x squared. So we can say standard deviation is equal to the square root of sigma x squared over n minus sigma x over n all squared, the square root of that. And we can simply substitute, and that will be 4,994 divided by 30 minus 354 divided by 30 squared, the square root of that. And we can simplify. The first part will give us 166.47 minus 139.24, which works out to be 5.22 to 2 decimal places will be the standard deviation for this data set. May 2022, number 6, part A. At a school canteen, 80% of the students, and we will represent that by S, purchase chips. We will represent that by C. And 55% chicken. Of the students who purchase chicken, 11% do not purchase chips. Let's look at part 1, where they're asking us to complete the following Venn diagram to illustrate this information. So let's bring up a Venn diagram in which there were 2 circles, and we saw C, K, and S to represent chips, chicken, and students. And look at the information we have. We actually do not know how many students purchase both chips and chicken, which is in the center, the intersection. So we can represent that using an X. But we know that there are a total of 80% of the students buy chips. So that circle C shows 80%. And if the intersection is X, then the piece to the left of it, which is chips only, will be 80 minus X. Because if we add up those two, we will get 80. Similarly, for chicken, there's 55% of the students purchase that. And if X is the intersection, then if they purchase chicken only, it'll be 55 minus X. And if we add the intersection and that on the right side, we will work out to be 55%. So it follows from the Venn diagram. Now, from this information, we should be able to calculate X. And how is that? Because it says that of the students who purchase chicken, only 11% do not purchase chips. So that means that 11 is equal to 55 minus X. Well, let's look at the diagram again and see that of those who fall into that circle of K, which is chicken, 11% do not purchase chips. So that means the right-hand side, 55 minus X, can be represented as 11. And if that's the case, we can now solve for X. If 11 is equal to 55 minus X, that means X is equal to 55 minus 11. So X is equal to 44. As such, we now know that there are 44% of the students are purchasing both chips and the chicken. And if X is equal to 44, then on the left-hand side, how many purchase chips only? 80 minus X. So 80 minus 44 is 36. So we have 36% purchasing chips only, 44% purchasing both chips and chicken, and 11% purchasing chicken only. And if we add that up, 36 and 44 is 80, 80 and 11 is 91. So how many students do not purchase chicken or chips? It will be 9%. And that will give us a total of 100% to cover all the students. So let's now move on to the next part, where it's asking us to determine the probability that a student chosen at random purchases only chicken, which is on the right hand side, or only chips, which is on the left hand side. So that will be 36 plus 11, which is 47%. Or we can write it as 0.47. So that is the probability of choosing such a student. Let's go on to the next part now, where in part B, the probabilities of occurrences of two events, A and B, are given by the probability of A is equal to 1/4, probability of B is equal to 3/5, and the probability of the union of A union B is equal to 7/10. So if we write an equation for such, because they're asking us to now determine probability of A intersect B, well, we can write probability of A union B is equal to probability of A plus B minus the intersection. And we can substitute and make probability of A intersect B the subject of the formula because we want to solve for that. So let's bring it across the left-hand side, and we'll get 1/4 plus 3/5. And if we move the union to the right-hand side, it will be minus 7/10. Now 1/4 is equal to 5 over 20 plus 3/5 is equal to 12 over 20. 5 over 20 plus 12 over 20 is 17 over 20 minus 7/10, which is 14 over 20. So if we do the subtraction, we'll get that the intersection is 3 over 20. And we go on to part 2. So determine, in part 2, the conditional probability of A given B. And we can write the formula, which is the intersection of A and B all over the probability of B. And we worked out the probability of A intersection B, and that was 3 over 20, divided by what's the probability of B given above, 3/5. So 3 over 20 divided by 3/5 means that 3 over 20 times the reciprocal, 5 over 3. 3 into 3, 1, 3 into 3, 1, 5 into 5, 1, 5 into 20, 4. So the conditional probability is 1/4. Part C. State with a reason whether events A and B are independent. So we know that the probability of A intersect B is equal to 3 over 20. And what is the probability of A times the probability of B? 1/4 times 3/5, which works out to be 3 over 20. So we can see that the probability of A intersect B is the same as the probability of A times the probability of B. As such, the events are independent. May 2022, number 6D. The following table shows the marks obtained by 27 students in a mathematics test. Construct a stem and leaf diagram to display this data. So let's bring up the table, and we can see the values for the stems, 3, 4, 5, straight up to 9. And the stem indicates that each one of these is multiplied by 10. And of course, with a stem and leaf diagram, what we'd like to have is a key. So if we had 3/0, that key indicates that that is equal to 30. And if we look at the table and looking at the marks, we could see in the 30s we had three values, 30, 35, and 39. So that's indicated in the leaf part as 0, 5, and 9. And in the 40s, there's 42, 45, and 45. So we see 2, 5, and 5 in the leaf. And with a stem of 5 representing 50, we have 52 and 59. So we should see 2 and 9. In the 60s, we have 61, 61, 65, and 69. In the 70, we have 5 of them, 70, 71, 75, 79, 80s, and of course the 90s. So this shows our stem and leaf diagram. And now let's look at part 2. State one advantage of using a stem and leaf diagram to display the data. The data is arranged compactly with no repetition of stem for different data. So if we look at the first row, we can see 30, 35, and 39. The 3 was not repeated, so it remained the same. That shows the compactness of the data. Let's go on to the next part. State the range of values of the marks obtained by the students. So when we talk about range, we're looking to see the difference between the highest mark obtained and the lowest. So we can substitute, that will give us 98 minus 30, which is 68. So the range is 68. Let's go on to part 4, where they're asking the data are displayed in the following box and whisker plot. The same data. 30 being the minimum, 52 being the first quartile, 71 being the second quartile or the median, 85 being Q3, the third quartile, and 98 being the maximum. State two distinct observations about the data as seen in the box and whisker plot. So let's take a look at it, and we can see that 71 is very close to the 85, Q2 is close to Q3, so we can say that the median Q2, which is 71, lies closer to the upper quartile, Q3, which is 85, than the lower quartile. So there's a larger space between Q2 and Q1 than Q2 and Q3, which means the data is skewed to the left, or it can also be said it is skewed negatively. Another observation we can say is that if we look at the values of the 27 students, half of the students scored from 30 to 71, a large range, and the other half scored from 71 to 98 because we can tell where the median is. So it shows that the lower half, there's a much greater spread, and the upper half is more concentrated. We have now come to the end of CSEC past paper questions in the topic of probability and statistics. This is the fourth section of the additional mathematics syllabus. In our previous video, we looked at all the questions in this section from 2012 until 2016. And in this video, we looked at the next 5 years. Remember that a year was missing due to COVID. Don't forget to look at the description down below, where we have outlined the order we suggest for you to go through the entire additional mathematics syllabus and the solutions of the past papers for you to get a better grasp of the entire subject.